Considerations for materials. One of the main attributes we need to consider when starting a sustainable design is our material choice. The material choice accounts for a multitude of important and different reasons, not only for your new design, but sustainability as well. Cost, performance, aesthetics, ability to decorate, sustainability of the material are just some of the key points need to be considered. Material choice is an important step in a design and in sustainable design. Due to this, I've listed over the next several slides important information to be considered. When making your material choice, how do you determine quickly if your material choice will be put on the path to a sustainable design? First, is the material recycled currently in the region your product will be disposed? Do not assume that because your material choice is glass, it is automatically recycled in every region. Or if you choose polypropylene that's filled, it's recycled just because it's PP. What are the other materials you plan to use, and does this affect the recyclability? Do you plan to use any additives, and does this affect it? Decoration expectations planned, and how does this affect the design and the recyclability of your chosen material? Make your own list based on your company's sustainability goals, product portfolio, and what your clients are asking from you. If we look at the four main groups of materials available, glass, plastic, biopolymers, and paper, what is the resource we need to protect and replenish in order to promote sustainability? With glass, main component is silica. With paper, cellulose fiber. Bioplastics are derived from plants, plant extracts, petroleum, and natural gas. Plastic, petroleum, and natural gas. Things to be considered when looking at glass. Glass in general must travel a long distance from the factory of origin to the buyer, thus the weight and distance can affect reducing your carbon emissions. Glass requires an enormous amount of energy to convert. Since glass is fragile, how much extra packaging do you need to transport it in its different stages? Lastly, the risk of dropping or breaking the glass when used by your customer also needs to be considered from a safety standpoint in your design. Paper. Ensure the paper you are using is sustainably sourced. Consider the end use of the product and features required. Not all features can be done in paper. Consider the expected life of a paper product versus another form. Paper does not have the greatest wear characteristics, so common wear situations can be a problem. Decoration of the paper can be done with non-petroleum based inks such as soy. And paper has a wide variety of deco techniques that can be used that are sustainable. Bioresins. Consider where your product may be sold, and do the local governments provide readily available solutions for depositing bio-based resins for recycle or industrial composting? Look at what stock material options are available, as well as the number of actual pounds of material available. Many bioresin manufacturers don't have a larger, broad portfolio of materials with ranging properties. Make sure you understand what kind of bio-based polymer you are buying. There are numerous grades which are combined with petroleum-based materials, organic cellulose fibers, and does this actually affect your recyclability? Then ask yourself, is it biodegradable, bio-based, or compostable? Considerations for plastic. Does your material choice fall within one of the first 6 codes, being PET, HDPE, PVC, LDPE, and PP, plus polystyrene? Many fall under number 7, which to the recycling industry equates to landfill, not the path of recycling the material. In the next slide, I've listed things to be considered when looking at plastic PCR for your design due to the large interest plastic PCR has recently generated. When looking for a supplier, you need to be diligent. Ask, what is their stream of recycle mainly derived from? Is it toys, batteries, food containers? Inspect the actual facility and see what and how they sort, wash, and extrude the material. How do they sort it? Do they float, NIR, IR, or a combination? How many times do they wash the material prior to recycling? How do they handle the contaminated water from the washing? Do they pre-blend and post-blend? Do they test every lot in-house? Do they run a vented extruder to pull off volatiles? Do they run the materials through a screen pack to remove as many contaminants, such as carbon or aluminum? Do they use a third-party lab for verification for certain tests, such as food contact?